Hello everyone, this is Sankarshan, and today I with my teammates Devasis and Manish are going to present on the topic durability of concrete. So getting into the presentation, these are the topics that we'll be discussing here. First we'll see the introduction and the objective of the study, then the different factors that are affecting durability, then some of the chemical and physical degradation that happens on concrete, and the different methods to enhance concrete durability and the case studies that has been happening, also the future trends in concrete durability, and finally we'll conclude. Okay, so starting, uh, so basically concrete is a very vital and the most commonly used building material, generally known for its strength and usefulness in construction projects, but there is more to it than just being strong. So we need to talk about its durability, how well it holds up over the time. Durability is about how long concrete can last and stay strong despite facing the harsh conditions like the extreme temperature or different chemical attacks or different type of harsh conditions. So the durability of cement concrete is basically its ability to resist different weathering action or chemical attacks or abrasion or any other deterioration. So durability of concrete is one of the most important properties because it is essential that concrete should be capable of withstanding all the different conditions for which it has been designed throughout its whole life. So this was the basic introduction. Next, the primary objective of our study is to explore the different factors affecting the longevity and the whole life of concrete structures, and also to understand how concrete lasts so long and how can we make it last even longer. How can we make it even resistant to different type of environmental conditions or different attacks that happens to it. So studying different methods to enhance the durability is primarily important to achieve a sustainable and long lasting building. So next is the different factors affecting durability. So the first one is concrete mix design. The selection and proportioning of the materials, in the concrete mix, like the cement or the aggregates or the admixture and the different other supplementary cementous materials, plays a very crucial role in determining its durability characteristics. While preparing the concrete mortar mix, we need to maintain a proper amount and proportion to achieve the required strength of the whole concrete structure. So it is the one of the most important steps to ensure a proper durable concrete. So next one being the quality of materials. Yes, selecting good quality materials like good grade of cement or good quality aggregates with proper gradation or proper shape and size will definitely help us to get the required strength and durability in our structure. The next one being the water cement ratio. It is also probably one of the most important factors because it changes the strength and durability drastically by increasing or decreasing the water cement ratio. So a lower water cement ratio generally results in a stronger and a denser concrete, having less porosity and less permeability, and helps us to get a good strength, and also makes the concrete more durable. So next one is the curing. So curing is basically maintaining proper hydration in cement concrete. So adopting a proper curing method helps us to maintain the proper moisture levels in concrete during the early stage. It also helps in promoting the hydration and helps in minimizing the cracks and all. So it basically provides the initial strength to the concrete and helps in maintaining the strength in a longer period as well. So the next factor being the environmental exposure. Exposure to the environmental factors like the moisture or the temperature variations, or maybe different type of chemical attacks like the chloride ion attacks or the sulfate attacks. All of this affects the durability to a long extent. It deteriorates the structure, and there are also many different reactions due to all this, like the alkali silica reaction and other chemical attacks, and all of this comes under the environmental exposure, and all of this degrades the concrete. So we need to keep a proper check on this environmental exposure and prepare our concrete so that it tackles all of this and maintain a good and be a good durable concrete structure. So the next one is construction practices. Proper construction practices like the right amount of compaction and consolidation, the proper placements of the materials during the construction period is essential to achieve a durable concrete. Next is the maintenance. Proper quality control and maintenance is also equally important. Implementing the quality controls and during the construction period and also after the construction is over helps in maintaining the life of the structure and plays a crucial role for ensuring the durability and the long-term performance of the structure as well. It helps in keeping a check in the different deterioration that happens in concrete and extends the service life of the concrete structure as well. Okay, so these were the different factors. Now, the different chemical degradation that happens in concrete. So the first one is the carbonation. Carbonation is basically when the CO2, carbon dioxide from the air reacts with the calcium hydroxide present in concrete or in the concrete, and they basically reduce the alkalinity of the concrete, and this results in decreasing the passivation. Now, decreasing the passivation means decreasing the upper layer or the upper coating in steel structure. Now, by decreasing this, it exposes it to moisture and the environmental conditions, which leads to the corrosion and decreases the whole strength of the concrete structure. Now, next one is the chloride attack. Chloride attack is generally caused when the structures are near the sea structure, sea water, or any type of industries are present where a lot of chemicals are chemical effluents are released. So this happens when the chloride ions penetrates into the concrete and it reaches the steel structures. Now now this chloride ions also creates or leads to the corrosion of the steel and hence reduces the whole strength of the steel and as well as the concrete. It basically does the depassive. It basically decreases the passivation as well, and yes, it causes concrete. It causes cracking as also. Okay, the next one is sulfate attack. Sulfate attack is when the sulfate ions penetrate into the concrete from the surrounding environment, generally from the soil, and it reacts with the calcium aluminate and the calcium hydroxide in cement paste and forms expensive compounds. So this expensive compounds like the gypsum or the attringite, they absorbs the moisture and increases in size. And due to that increase in size, they leads to cracking and spalling, and hence leads to the deterioration. Next is alkali aggregate reaction. Generally, the aggregates that we use are inert in nature and does not react, but there are some aggregates that have some siliceous materials or are reactive in nature. Those aggregates reacts with the alkali hydroxide, like the sodium or potassium hydroxide in cement, and they also form gel-like substances that increase in the volume by absorbing the moisture and leads to cracking and deterioration. So the next one is acid attack. Acid attack is basically when chemical acids uh, reacts with the concrete and removes the upper layer of the concrete, causes surface erosion and loss of mass. This also decreases the durability of the concrete in long run. So these were the different physical degradation that happens in concrete. Now we have some physical degradation in concrete as well.
So from now we're discussing the physical degradation or deterioration of the concrete. As the name suggests, it can occur through scaling, corrosion of reinforcement, delamination, erosion, and many more. So we'll discuss some types of physical degradation from now. First one is freeze-thaw damage. The freeze-thaw cycle is a major cause of damage to construction materials such as concrete and brick assemblies. Freeze-thaw damage occurs when water fills the void of a rigid porous material and then freezes and expands. It occurs in regions with high temperature fluctuation and high moisture content. Then the next one is thermal expansion and contraction. Variation in temperature can lead to expansion and contraction of concrete, which further leads to development of stresses and cracks, and more cracks are developed. So this phenomenon also occurs in the region where the large temperature fluctuation occur. Yeah, next slide. Next one is shrinkage cracking. While curing and drying of the concrete, shrinkage occurs due to evaporation of water and and many other hydration reactions. If it is if it restrictions are occurred by reinforcement or other external factors, then tension develops and cracking occurs, reducing the durability. Abrasion. It occurs when surface layer of concrete is subjected to abrasive force or repeated friction, such as vehicular traffic, footpaths, or other abrasive material. In due course of time, the surface layer of concrete wears down and leading to loss of thickness, roughening, and degradation of surface properties. Yeah, next slide. Next one is fatigue cracking. Fatigue is the progressive damage due to propagation of cracks and is considered to be the primary cause of structural failure in concrete pavement. This type of mechanical degradation is common in structures such as bridges, pavements, and industrial floors, where cyclic loading from traffic or machinery causes progressive cracking and deterioration. Next is creep and deformation. Concrete creep is defined as deformation of structure under sustained load, basically as long-term pressure or stresses on concrete can make it change of shape. This deformation usually occurs in the direction of the force being applied. Excessive creep can lead to long-term deformation, settlement, or structural instability, particularly in concrete elements subjected to sustained loads or temperature changes. Next slide. Yeah, joint deformation. Joints in concrete structures such as expansive joints, construction joints are susceptible to mechanical degradation due to movement, settlement, or inadequate sealing. Improper joint design or maintenance can lead to joint failure, water infiltration, and deterioration of adjacent concrete elements. Last one is impact damage. It occurs due to impact loading of heavy objects, machinery, vehicular collision, or dynamic forces that can cause localized damage, fracture in concrete elements. This type of mechanical degradation is often observed in industrial floors, bridge decks, pavements, and structures subjected to heavy traffic or dynamic loads. Next. Methods to enhance concrete durability. Enhancing concrete durability involves employing various techniques and strategies to improve its resistance to deterioration and prolong its service life. Here are some common methods to enhance the concrete durability. Proper mix design. We should optimize the concrete mix proportions to achieve desired strength, workability, and durability properties. We should also consider factors such as water cement ratio, aggregate grade, supplementary cementitious materials, and chemical admixture to enhance the durability. Next one is low permeability concrete. We should use concrete mixes with low permeability to reduce water penetration and entry of aggressive substances such as chlorides, sulfates, and acids. We can employ dense aggregates, reduce water cement ratio, and incorporate pozzolanic materials which can help to improve concrete impermeability. Next slide. Corrosion inhibitors. You should include corrosion inhibiting admixtures or surface treatment to protect embedded steel reinforcement from corrosion. These inhibitors create a protective layer on the steel surface, reducing the rate of corrosion in aggressive environments. Next is concrete sealers and coatings. Applying sealers or coatings to concrete surfaces to provide a protective barrier against moisture, chemicals, and abrasion. Sealers can also help to reduce water absorption, inhibit chloride entry, and enhance surface durability. Next one is curing practices. We can implement proper curing techniques to maintain adequate moisture and temperature conditions during the initial stages of concrete curing. Adequate curing promotes hydration, improves strength, development, and enhances durability properties. Next slide. Next one is air entrainment. We should include air entraining admixtures to create microscopic air voids in concrete, enhancing its resistance to freeze-thaw cycles. Air entrainment improves concrete durability in cold climates by reducing the potential for damage and freeze-thaw induced cracking. Next is surface treatment. Proper jointing and construction practices. We should install control joints, expansion joints, and proper reinforcement detailing to accommodate thermal and structural movements, reducing the potential for cracking and determination. Next, the last one is quality control and maintenance. We should implement stringent quality control measures during concrete production, placement, and curing to ensure consistency and durability. Regular inspection, maintenance, and repair of concrete structures are essential to identify and address the potential durability issues before they escalate. Now,
We are going to see various case studies that has been conducted on the durability of modern concrete. First one is the bridge decks. Bridge decks case study is conducted on Severn Bridge, which is located in United Kingdom. The Severn Bridge features a concrete deck constructed using precast segment post-tension reinforcement. Despite exposure to marine salt spray and heavy traffic loads, the bridge deck has maintained in its structural integrity over several years, showcasing the durability of modern concrete construction. The second case study is marine structure. The marine structure case study is conducted on Burj Al Arab, which is located in Dubai, which features a concrete foundation and marine structure designed to withstand the corrosive effect of sea water and high winds. Then next slide, please. The next case study is nuclear power plant. Concrete that is used in nuclear power plant is capable of withstanding exposure to ionizing radiation emitted by radioactive material. Over time, radiation can include chemical and physical changes in concrete, potentially compromising its structural integrity. Therefore, concrete formulation with low porosity and higher density aggregate are preferred to minimize radiation-induced damage. Concrete structure in nuclear power plants are often exposed to aggressive chemical environments, including high alkalinity, chloride ingredients, and sulfate attack. Next case study in transportation infrastructure. So transportation infrastructure case study is conducted on Gotthard Base Tunnel, which is located in Switzerland. The Gotthard Base tunnel feature concrete lining design to withstand high temperature, pressure, and mechanical stresses. Despite the challenging geological condition encountered during construction and heavy traffic, it facilitates safe and efficient rail transportation throughout the tunnel. Next one. Now we will going to see various future trends in concrete durability. Future trends in concrete durability are likely to be shaped by technological advancement, sustainable consideration, and evolving infrastructure needs. First future trend is sustainable solution. Increasing emphasis on sustainability and environmental concern is driving the development of eco-friendly concrete solution with reduced carbon footprint, lower embodied energy, and enhanced durability. The next future trend is innovative materials. Continued research and development of advanced cementitious material such as high performance concrete, UHPC, geopolymer, and self healing concrete offer improved durability properties, including enhanced strength, reduced permeability, and resistance to. The next future trend is resilient infrastructure design. With increased frequency and severity of natural disaster and climatic related hazards, there is a growing interest in designing concrete structure for resilience and adaptability. Resilient design strategies such as incorporating redundancy and multiple hazard resistance into infrastructure system aim to enhance durability. The next future trend is nano and micro technology. Integration of nanotechnology and microtechnology into concrete materials and construction practices enables the design of concrete with different properties at the molecule and microstructural level. Nanoparticles and nanofibers can enhance the mechanical properties such as durability and improve the particle dispersion, reinforcement, and surface modification. Next one. Now coming to the conclusion, in conclusion, the durability of concrete, it remains a critical aspect of infrastructure development and construction project worldwide. Over the years, the advancement in material sciences, construction techniques, the sustainability practices have significantly improved the durability of concrete structure. Concrete has a unique ability to resist environmental degradation, chemical attacks, mechanical stress, and other forms of deterioration, which is crucial for ensuring its longevity, and performance of infrastructure assessed. Innovation such as high performance concrete, mixes, supplementary cementitious material, and advanced construction method have contributed to enhance concrete durability in diverse application and environment. Various case studies highlight the diverse application and environments in which modern concrete technology demonstrate durability, resilience, and longevity, contribute to the construction of iconic landmark, critical infrastructure, and sustainable built environment around the world. In overall, concrete's durability remains cornerstone of sustainable development and safety in the built environment. Embracing sustainable practices and adopting proactive maintenance strategy, concrete will continue to serve as a durable and reliable building material for a wide range of infrastructural application. Next one. So thank you. The references we have taken is from recent durability studies on concrete structure and a review on concrete durability in India, framework for performance based approach. So thank you everybody.